Welcome back to How To. On today's How To video, I will explain you how to configure and set up our laser disable button to enable laser emission on our PHAENON accurate or on our AVB hardware. Of course, the same would apply for our RTI PIKO projectors. Our laser disable button is a PoE powered button, so that means it doesn't need an additional external power supply, but you will need either a PoE switch, such as our Luminex gigacore we have here, but it could also be a different one. It doesn't need to be this specific model. You can of course also use a PoE power injector. It's very easy. You see our laser disable button has a key, has a push button, and on the other side an EtherCon. Connection of our laser disable button is pretty straightforward. Just take your network cable and plug it in to the network port of the laser disable button. As soon as it's powered up, it will start blinking. We have three different blinking states. We have one, it's basically this one, so it means button has been released but the key is still off. We have another one where it blinks very fast when the button has been depressed. And finally, the last one, when the button is released and the key is on, it's steady on. So steady on means you could now have laser emission if the device has been correctly configured. But before having laser emission, we have to tell each laser projector the IP address of the laser disabled button it has to listen to. For that, you will need our LA.toolbox monitoring software. Just open it. As you see it here on my screen, I do have basically two items. I have on the right my AVB to ILDA. It's one of those converters which is already in run state, so you see with the laser warning symbol. And the second one, it's my PHAENON accurate there, which is on standby. Why? Because I left it on standby. If you want to assign the IP address of this disable button, simply go to the safety tab of the laser, and on the bottom you will see laser disable. You can assign up to 4 different laser disable buttons per laser projector. That can be very useful, especially if you have a lot of lasers or on different locations on stage. You could assign, for example, laser disable 1 will be a master kill, so that button will switch off every laser being on stage. You can assign a laser disable 2, which will, for example, only kill or switch off laser emission for laser being on stage, while laser disable 3 will be, for example, just for some volumetric or aerial effects. To assign a laser disable button to a specific device, of course, you need, well, either you know the IP address from the device, then you can simply type it in the fields here, or you can select the drop-down menu, and it will simply list all available laser disables which are detected in the network. In our case here, I just have one, so it's why I only have one IP address being shown. Now, very important, you also have to click to on to activate a laser disable button. Now you see it immediately goes to enable, so it receives the status of that laser disable button. If I put the key to off, you see its immediate laser disable button communicates with LA.toolbox and the laser, of course, and the laser knows, oh, the key has been switched off. The same thing would happen if I depress the button, it goes red, it shows you button. You might have seen in the background that my AVB to ILDA also changed its current operating state. It went from run to now currently standby, and left to it says laser disable 1 button. So you see the current state being standby, but also the reason why. And the reason here is because I pushed the button and this caused that hardware to go to standby. If now I release the button, it still tells me standby laser disable 1 key, because I need to do the key latch or key switch, so going from key on to off and back on, and this will re-enable laser emission on that hardware. Now we can simply test the same thing for our laser projector. So I will simply go to run, and as you see, I do have a small emission or small animation from our SD card. As soon as I will depress the button, the laser emission is immediately killed. It's not only laser emission on PHAENON or on PIKO which is switched off, but also the entire scanning. So the mainboard takes control of basically everything. Here again, as on the AVB interface, you see current state or status being standby, Y laser disable 1 button. If I release it, it will tell me key. Now we go to off and back on, and both hardware go back to run. You can also, on the safety tab, we have a timeout. That one can also be set to a different value, for example to 1 second, which means that if the connection has been lost, for example a switch failure or a cable failure, you see it immediately went to timeout, meaning it didn't receive any information from the disable button for a specific time, and so laser emission goes off. On next video, next how-to video, I will explain you how to configure our laser disable software, which is basically the same as our physical disable button without the key. So you won't be able to do the key latch, but it shows you also some very interesting monitoring options to have a monitoring of different laser disable buttons over the network. Stay tuned for more.